Welcome. So today we're going to talk about graphing trig functions. So we're going to begin with graphing 5 sine open parentheses x, or sorry, 1/2 x plus pi over 3 close parentheses. So I've written here in black the standard form of the sine function. So I have my 4 constants here, A, B, C, and D. So each of these does something different in the graph. So we're going to start by graphing, we're going to do 3 separate graphs. We're going to do a simpler version and then get it more complex as we go. So there is no C in my equation here. There is no plus anything. C represents the vertical shift, which means that whatever I do to my graph, no matter what happens, it is going to be centered around that x-axis. It's not shifting up or down. So as just a side note over here to the right, I'm just going to recall what the sine function looks like. So the sine function looks like this. It passes through the origin. So that's generally the shape. And now we're going to see what alterations we need to make. So the first thing that we'll graph will be, I'll do some different letters here, although h of x as 5 sine of x. So here, the only thing I'm changing is that first number, that a value. Now, this is the amplitude. So if I'm graphing 5 sine x, then what I need to do, try to make this neat, is I'm going to start at the origin, and I'm just going to draw the same graph. I'm not going to do anything different. I'm just going to draw it. And then the beauty of you being in charge of your graph is that I can just say, this is 5, this is -5. So I have adjusted my amplitude without having to do any real change to the graph. It's a basic graph. I just am changing my labeling. So here I have 5 and -5, and I should label this as my y-axis, and this is my x-axis. So then the next thing I want to do is, we'll call it G. Oh, let's do a different color. Let's do black. So G of x is going to be 5 sine of 1/2 x. So I'm just looking at each component individually and seeing what it does. So this number here, this b value that's inside, this changes my period. So the standard period for sine is 2 pi. So in order to find my new period, I divide 2 pi by 1/2. When I divide by 1/2, I do multiply by the reciprocal, so I end up with 4 pi. So what that means is that it takes this graph twice as long to go through its cycle, right? Or I guess the period is twice as long. So it's half as fast is one way to think of it. Twice as long the period. So there's a couple ways of thinking about that. Let's go ahead and graph that. So here I'm going to start again with my x and y axis. And again, I'm not going to change anything. I'm going to draw just a basic sine curve. It should be a little neater than that. I'm sorry, it's a little pointy. I'm not an artist. And I'm going to label again, this is 5, this is -5, taking care of that. And instead of actually changing the way my graph looks, I'm just going to change these labels. So where this, in the standard graph, I'm going to go back over here to the red, this is 0, of course, this is pi, and this is 2 pi. So it takes it, in order to do a full cycle, it's 2 pi. Here, it takes me 4 pi to do a full cycle. So this, oops, let's change back to black. This point here is going to be 4 pi, which means that this is half of it. That's 2 pi. I can label these ones if I want, -2 pi, -4 pi. But I would say that that's not necessarily necessary. For me as the instructor, you've labeled that 2 pi and that 4 pi, then I think that you're doing well and you've indicated clearly what is happening. All right, so now I'm done that. I need to address my final equation here. So let's go ahead. We'll do it in green and see how that goes. Oh, that doesn't look dark enough. Let's just go back to blue. Sorry. So I'm going to draw it over here and to the right. I'm going to draw a line here and indicate that I'm drawing over here because I want to keep it all on the same page so you can still see everything. Let's go ahead and call this J. Oh, I don't need to call it J. I already have something that's called. It's called F. So that was the original problem statement. F of x equals 5 sine of 1/2 x plus pi over 3. So something that's worth noting is that this form doesn't exactly match what I have here. In my standard form, this black equation, it's the coefficient b times the quantity x minus d. So d represents our horizontal shift. Where are we moving to the left and the right? But my format doesn't match here, so I need to rewrite it using this standard format in order to make my life easier. So I'm going to call this f of x. 5 sine x, that's all the same. I need to factor out a 1/2. So when I factor out a 1/2, what I'm doing is I'm dividing pi over 3 by 1/2. So that should give me pi over 6. Yeah, because then when I multiply the 1/2 back through, oh no, I'm sorry, that's wrong. Why? I got excited about pi over 6. It should be 2 pi over 3. So 2 pi over 3. There we are. So what I've done here is I've divided the pi over 6 or the pi over 3 by 2. If I multiply this 2 back through, if I distribute it back in, I get 1/2 x, and then 1/2 times 2 pi over 3, that gives me back my pi over 3. So that's what I've done here. I divided that by 1/2. This is my horizontal shift. Because it is a positive value, this is the kind of thing about these, is that it goes the opposite direction you think it should go in. So this is a positive value, so my function here is going to be shifted to the left. So shifted 2 pi over 3 left. All right, so now I'm in good shape. So again, now I'm going to draw my equation here. I do have to be a little bit careful because in this instance, I can't just draw my standard sine because I need to account for that horizontal shift. So I can't just draw my basic sine function where it is, right? But I know I'm going to be shifted to the left. So what I usually do in when I'm working on these problems is I say, okay, well, I need to shift 2 pi over 3 to the left. So instead of my function hitting at the origin, it's going to hit here. And I'm just going to call that point negative 2 pi over 3. And then I need to evaluate some other points. So if I'm looking at my previous equation or my previous graph, I was hitting here at 2 pi. That's the next time I touch the x-axis. But instead of hitting at 2 pi, I need I need the next point that I hit my x-axis to be 2 pi minus 2 pi over 3. In order to divide or to subtract my fractions here, I'm going to change this 2 pi into 6 pi over 3. So I have 6 pi over 3 minus 2 pi over 3. That's going to give me 4 pi over 3. So then I'm just going to call at this point here, I'm going to call that 4 pi over 3. And it's possible my drawing's not perfectly to scale, but I think that as long as you're labeling your points, you're doing well and you're going to be okay. If you'd like to graph it more exactingly, you can do that. But for me, we're labeling our points in order to avoid any confusion. So I'm going to draw my sine here and here. Okay. Now, again, I'm going to say that this is 5. This down here is negative 5. And, I've more or less done it. If I want to graph this last point here, just to give one more data point, I can go ahead and add 2 pi to 4 pi over 3 because that's the next point, right? The next time that my function touches the x-axis will be 2 pi later. So 4 pi over 3 plus 6 pi over 3, that's going to be 10 pi over 3. And then you have, once you've added that 10 pi over 3, then you have a really nice graph. You have really nice points there. So this is how we graph the sine function. We do each piece individually. If there is a c value, then you do need to handle the vertical shift, but we did not have that this time. So this time, this is how we go ahead and graph this. Thanks so much.